Okay, welcome to Unit 11, Day 2, the binomial theorem. Who's ready? As you can see, there's your OBJs for the day. Let you read down here in a second and we'll get going. Okay. So binomial theorem, as you can see, we're going to do what's called Pascal's triangle will come into play here. We're going to expand binomials. Okay, so here's the binomial theorem. Now I know it looks kind of like a foreign language, if you will. Do we really need all this information? No. This is important right here. This will find a specific term. We'll talk about that in Unit 11, Day 3, a little more specifically. You did this part in Algebra 2, NCR. That's a combination, okay? But there's the formula, n factorial over n minus r factorial times r factorial, okay? So I'm going to show you a little shortcut using either a calculator or Desmos for that. All right, so let's first practice doing some combinations. So this 8C2, the n is 8, the r is 2. So if we were to expand this and simplify, it would be 8 factorial over 8 minus 2 factorial times 2 factorial. Now that exclamation point means factorial. What that really means with the 8 is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so start with that number and you multiply every number after that until you get to 1. This 8 minus 2 is 6, so that's going to be 6 factorial. And then 2 factorial is 2 times 1. Okay, now we can clean this up a little bit. See how we have the 6, 5, 4, 3, 2, 1? We can simplify that with the 1 down here. All right, because if you have the same thing on top and bottom, they can simplify. This 2 and this 8 can simplify. So what we have left up top is 4 times 7, which is 28. 1 times 1 is 1, so you end up with 28. All right, now let me show you a shortcut. See if we can get this in here. So with our friend Ralph here, we got our calculator. So first of all, this, the 10 and the 3, this really means 10C3. So your n is 10, your c is 3. Now on the calculator, let me see if I can squeeze all this in. So I need to put the 10 first. You did this last year in Algebra 2, but do you remember? So put the 10 first because that's the first number. Now we have to go to Math, and then arrow to the right under probability, okay? And it's right there, option 3. So I hit enter, and then I put my 3, I hit enter again, and that does it for us. Okay, so that's a nice shortcut. Okay, so again, we hit the math button, go over to probability, there it is. But remember, you gotta put that first number in before you go to there, okay? So we end up with 120. Now, worst case scenario, you could use the formula. Okay, so this would be 10 factorial over 10 minus 3 factorial times 3 factorial. Okay? All right, let me show you another way on how to do this on Desmos. So here we have 7C0. So let me slide over here to Desmos. See how well I can do this here. All right, so I have to click on, where is my cursor? Here we are. All right, so this isn't very steady. But you got to click on that arrow to get the keyboard. You come over to Functions. And I already have it under Stats, but you want to hit the Stats. And then you hit your NCR. And that will appear in the basic screen. Okay? Now, this problem was 7C0. So if I want to use Desmos, you put the 7 in first, comma, 0. and then close the parentheses. And see how, I don't know why I did that. There we go. And then see how the final answer is 1. So that's how you do it on Desmos. Okay? Bring it back over. All right, so we ended up with a final answer of 1. Okay. Now, this is what we call Pascal's triangle. So we have to know, what row we're on to help us out. All right, and the way this, if I put an imaginary 0 here, this will tell us what row we're on. Okay, so row 0, row 1, row 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's the second number tells you what row you're on. Now, to build this, anywhere you go, if I pick 2 numbers, these 2 numbers added up gives us that number. If I go here, these 2 numbers added up gives us that number. These 2 numbers added up gives us this number. Okay? So if I want to build one on my own to get going, this is what it's going to look like. Always start with a 1 and then 1, 1, so that's kind of given. Now, notice how we had the 1s on the outside. Now to get this number, 1 plus 1 is 2. So there's row 2. Those are the numbers that are important to row 2. Now this is row 3. 1 plus 2 is 3. 2 plus 1 is 3. So this is how we build Pascal's triangle. Row 4, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then don't forget you always start with 1, you end with 1. Okay, let's do one more row. 1 plus 4 is 5. That gives us 10. That gives us 10. That gives us 5 and 1. So that would be row 5. So those are the key numbers in row 5 and so on. Okay, so again, if we build this over and over again, this will get us up to row 10. Okay. All right. So let's expand these binomials. Now, back in Algebra 1 and Algebra 2, when you did these, you would have to take, if I go down here, for example, x plus y to the 5th power. That would be x plus y times x plus y times x plus y times x plus y times x plus y. 5 of them. That would be a pain in the butt to multiply. So that's why Pascal's triangle and this binomial theorem is going to help us out. So now the first one, anything to the 0 power is 1. So there's your answer. Now I'm going to put it there because it's in the middle, and you'll see why here after we get all these answers. So if I want to expand this one, okay, because this is a 1, that's what row we're on. Now from the Pascal's triangle, that's row 1. Those are the two key numbers from row 1. Okay? If I go to the next one, this is row 2. So these are the key numbers from row 2. If I go to this one, row 3, those are the key numbers from row 3. This one has a 4, so the key numbers from row 4. Okay, and then one more, the row 5. All right, so that's how you start it. Now you could do all these individually. So for example, if I'm starting here, I want row 4, I need those key numbers first. Okay? Now the first one's done. Anything to 0 power is 1. Now here's how we kind of finish this. We take this first guy, raise it to that power. Okay? And then we continue it until we get to 0. So we take x to the first and then x to 0. Now we're going to take this guy to that first power, but we're going to start here at the end. So it's going to be y to the first, y to the 0. You go backwards for that second number. Now all of these are plus, as you can see, so we're going to have a plus in the middle. Now if you were to clean this up, remember anything to the 0 power is 1. So that's going to be 1, that's going to be 1. So we're really going to be just left with x plus y. 1 times x times 1 is x. 1 times y is y. So you just get x plus y, which, that's what it is, right? Now this next one, again, this first guy, raise it to the second power, and then you go in descending order till you finish. okay? This y raised to the second power starts here, and you go backwards. Plus signs in the middle. And you would clean that up. So this would be x squared plus 2xy plus y squared. Okay? All right, let's try this one. So x to the third would start here. And then you go in descending order. And then this guy is to the third power. So you start here on the right side and you go backwards. Now notice how, if you look at any one specific term, what do these exponents add up to? 2 plus 1 is 3. Boom. 1 plus 2 is 3. You know, so you could get that anywhere in there. Plus signs go in the middle. So if I clean this up, we get x to the third plus 3x squared y plus 3xy squared plus y to the third. Okay? All right, so I'm going to continue our process here. All right, so you start with the x, raise to the fourth, go in descending order from left to right. The second guy, you raise it to the fourth power, but you go in reverse. Put plus signs in the middle. Clean that up, you would get x to the fourth plus 4x to the third y plus 6x squared y squared plus 4x y to the third plus y to the fourth. Okay? All right, here we got x to the fifth, x to the fourth, x to the third, and so on. You go in descending order. We got y to the fifth, so we can start here on the right side. Remember, all these exponents, the 2 will add up to 5 in this case, because that's what row we were on. Don't forget your plus signs. Okay? So, clean that up, you get x to the fifth plus 5x to the fourth y plus 10x to the third y squared plus 10x squared y to the third plus 5x y to the fourth plus y to the fifth. Okay? All right. Now, so this example, excuse me, if looking at this, we want to use the fifth row to find this, and, we're dealing with row 5. Okay? I'm sorry, row 6. We want to get row 6. My mistake. So 2 ways we could do this. We could do this, and this will get us all our coefficients. So notice how we start with 6, and we have 0, 1, 2, 3, 4, 5, 6. So if I were to clean all those up individually, I would get the row 6 numbers. The other way to do this is use the previous row, which would be row 5. So the key numbers to row 5 are 1, 5, 10, 10, 5, 1. Now, to get row 6, I would add these guys, and so on. So that gets us the key numbers to row 6. Okay? So you can see here that 6C0, if you clean that up, you get 1. If you clean this up, you're going to get 6. Clean this up, you're going to get 15, and so on. So I'm just showing you 2 different ways. We really don't have an example like this for homework. I'm just kind of pointing that out. Okay? All right. Example 3. All right, so we have to expand this binomial. All right, so here is the process. First step. Realize what row you're on. We're on row 3. Okay? So we need the key numbers from Pascal's triangle. So row 3 would be 1, 3, 3, 1. Okay? Those are the key numbers from row 3. Now, take your first guy here, x, raise it to that third power. So x to the third, x to the second, x to the first, x to the 0. So you always go in descending order. Take the second guy, which is 1, raise it to that third power, but you start here. So 1 to the third, 1 to the second, 1 to the first, 1 to the 0. Okay? Because that's a plus, we got plus signs in the middle. All right, so that's how you expand it. Now let's clean it up. So 1 times x to the third times 1 to the 0. Now this 1 to 0 is 1. So we just end up with x to the third. This one, the first is 1 times 3 is 3 times x squared is 3x squared. 1 squared is 1 times 3 is 3 times x is 3x. And then x to the 0 is 1. 1 to the third is 1, so we're just going to get 1. So that's how you expand that binomial, using the binomial theorem, using our Pascal's triangle to help us out as well. Okay? That's a whole lot easier than taking x plus 1 times x plus 1 times x plus 1. All right? Now, the higher the exponent, the more time you're going to save doing it this way. All right, let's look at letter B. Row 4, so 1, 4, 6, 4, 1. Those are your key numbers from Pascal's triangle. Okay? Take your first guy, raise it to the 4th power. Go in descending order. And then don't worry about the minus sign here. I'm going to show you a little trick here. So just take the 3, raise it to that 4th power. And go in backwards. Okay, so that's how you get the individual terms. Now, going back to letter A, if that's a plus, they're all plus. If it's a minus, what we do is we alternate plus, minus, plus, minus. First guy is always positive, so the first sign you actually write is minus. Plus, minus, plus. So you just alternate, okay? Okay, now this one's a little harder to clean up, but we can do it. 3 to the 0 is 1, times 1 is 1, times x to the 4th is x to the 4th. Okay? 3 to the 1st is 3, times 4 is 12, times x to the 3rd. Now this one we do 3 squared, which is 9, times 6 is 54, times x squared. Okay, now this one, 3 to the 3rd power is 27, times 4 is 81, times x. X to 0 is 1, 3 to the 4th is 81, times 1 is 81. So there's your expansion on that one. Okay. All right, one last one, letter C. This one gets a little bigger. So I'm going to start down here, row 5. So 1, 5, 10, 10, 5, 1. So those are the key numbers from Pascal's triangle. We got x to the 5th to start. Go in descending order. So remember this process. Here we have y to the 5th. Again, don't worry about that minus sign just yet. So y to the 5th, we start on the right side and go backwards. Okay. Now, because that's a minus, we alternate positive, minus. So the first sign you actually write is that minus. Plus, minus, plus, minus. Okay. Clean it up. You're going to get x to the 5th here when you clean it up. Remember, y to 0 is just 1. Okay, so this is really pretty easy when you clean this particular one up. Sometimes it gets a little more challenging. And that is your binomial theorem. Okay? All right, so that concludes Unit 11, Day 2. So we got a question of the day here. What has 6 faces but does not wear makeup, has 21 eyes but cannot see? What is it? All right, so if you know the answer to that question, you can email that to me. And okay, so that concludes Unit 11, Day 2. Go Cougars!